Hi guys, welcome to my video. So let me introduce myself. My name is Priyamti Widyamaharani, or you can call me Rani. I'm from 4D class of Education Mathematics with my last name number is 0385. So today we will talk about transformation. But do you know what is transformation? You can see in your daily life, just like caterpillar turn into a beautiful butterfly. Yeah, that's called transformation. But in biology, it's called metamorphosis. So, do you know what is transformation? In general, transformation is the act, state or process of changing, such as in form or structure. But in this video, we will talk about transformation in geometry. So, what do you know transformation in geometry? Transformation in geometry is the study of objects that have been moved or changed in some way. In geometry, there are four basic types of transformation. There are translation, or in Indonesia is translasi. The second is rotation, or in Indonesia it's called rotasi. The third is reflection, or Indonesia is called refleksi. And the last one is dilatation, or in Indonesia it's called dilatasi. Now let's discuss about translation or slide. In Indonesia it's called translasi or pergeseran. In geometry, translation simply means moving without rotating, resizing, or anything else, just moving. Definition of translation in math is a translation move a shape left, right, up, or down, but doesn't turn. The translated shape or the image appear to be the same size as the original shape, indicating that they are congruent. They simply shift in one more direction. There is no change in the shape because the shape simply moved from one location to another. Okay, now let's move into translation on the coordinate plane. Any object in the coordinate plane can be moved horizontally up, left or right, or vertically up or down by translating in the coordinate plane. Okay, now let's look at an example to see how coordinated plane translation works. As shown in the graph, a quadrilateral has been represented in the coordinate plane. The quadrilateral is shifted 5 units horizontally to the right and 1 unit vertically upward during the translation. The resulting new translation function for the given figure being x, y into x plus 5 and y plus 1. Each of the x-coordinate of the vertices have to be added by 5 units, and each y-coordinate will be added by 1 unit. Now let's move into translation rule. For the following translation, let's understand the change in the coordinate of the image form. There are 4 rules in the translation. Number A, replace x with x minus k when the shape is moved to the left by k units. Number B, replace x with x plus k when the shape is moved to the right by k unit. Number C, replace y with y minus k when the shape is moved to the down by k unit. And the last one, number D, is replace y with y plus k when the shape is moved to the up by k unit. Okay, now for the example. When the translation x, y into x minus 2 and y plus 3 is applied to the point 2, 5, what are the new coordinates? Okay, let's check it out the solution. Consider the point to be a x, y into 2, 5 and let the image be a accent. Now, using the transformation provided, apply it to this point. X x minus 2, and then we substitution the x into 2, and then we got 2 minus 2 equals 0. And then y plus 3, we substitution the y into 5, we got 5 plus 3 is equal to 8. As a result, coordinates of the image of point A are accent 0, 8. Now we gonna go to rotation or rotasi in Indonesia. So what is rotation? What is the definition of rotation? Yeah, the transformation that rotates each point in a shape at a certain number of degrees around the point is called rotation. Yeah, it's simply called turning around the center. Another definition of rotation means the circular movement of an object around a center. It is possible to rotate different shapes by an angle around the center point. Mathematically, a rotation means a map. All the rotation around a fixed point that make a group under a structure are called the rotation group of a unique space. When coming to the three-dimensional shapes, we can turn or rotate the object about an infinite number of imaginary lines, known as rational axes. Now, one might have the question of what the rotation of axis is. Here is the answer. The rotation around x, y, and z axes are known as the principal rotation. Okay, there are formula of rotation. Rotation can be done in the both direction, like clockwise as well as counterclockwise. The most common rotation angles are 90 degrees, 180 degrees, and 270 degrees. However, a clockwise rotation implies a negative magnitude, so a counterclockwise turn has a positive magnitude. There are specific rules of rotation in the coordinate plane. You can see in the slide. Next, you can see the example of order of rational symmetry. The above example shows the rotation of a rectangle 90 degrees each time. The rectangle has the rotational symmetry of order 2 because when it is rotated twice, we get the original shape at 180 degrees. And again, when it's rotated twice, the original form is obtained at 360 degrees. So, the order of rational symmetry of the rectangle is 2. Now we will discuss about reflection or reflexy. The type of transformation that occurs when each point in the shape is reflected over a line is called reflection. Reflection simply known as a flip. A reflection is a mirror image of the shape. An image will reflect a line, known as the line of reflection. A figure is said to reflect the other figure, and then every point in this figure is equidistant from each corresponding point in another figure. The reflected image should have the same shape and size, but the image faces into opposite direction. In reflection, translation may also occur because of change in the position. Here, the original image is called pre-image, and its reflection is called the image. The representation of pre-image and image are A, B, C, and A accent, B accent, and C accent, respectively. The reflection transformation may be in reference to the coordinate system x and y axis. There are four types of reflection in the coordinate plane. So the first is reflection over x-axis. When a point is reflected across the x-axis, the x-coordinate remains the same, but the y-coordinate are transformed into their opposite sign. Therefore, the reflection of the point x, y across x-axis is x, minus y. The second is reflection over y-axis. When a point is reflected across the y-axis, the y-coordinate remains the same, but the x-coordinate is transformed into an opposite sign. Therefore, the reflection of the point x, y across y-axis is minus x, y. Third is reflection at origin. In the coordinate plane, we can use any point as the point of reflection, but the most commonly used point is origin. Let ABC be the triangle, and the coordinate are A is 1, 4, and the B is 1, 1, and C 5, 1. After the point of reflection is origin, the pre-image ABC is transformed into A accent, B accent, and C accent. When you draw a line segment connecting the point A and A accent, the origin should be the midpoint of the line. Therefore, the point of reflection in origin 0, 0, the image of the point x, y is minus x, minus y. Hence, the coordinate of the triangle A accent, B accent, and C accent are A accent is minus 1, minus 4, and B accent is minus 1, minus 1, and the C accent is minus 5, minus 1. Okay, now the last type of the reflection in a coordinate plane is reflection on a point. A reflection point occurs when a figure is constructed around a single point known as the point of reflection or center of the figure. For every point in the figure, another point is found directly opposite to it on the other side. Under the point of the reflection, the figure doesn't change its size and shape. Okay, now let's move into dilatation, or in Indonesia it's called dilatasi. The transformation that causes the two-dimension shape to stretch or shrink vertically or horizontally by a constant factor is called the dilatation. Dilatation is the process of changing the size of an object or shape by decreasing or increasing its dimension by some scaling factor. For example, a circle with radius 10 units is reduced to a circle of radius 5 units. The application of this method is used in photography, art, and craft to create logos or anything else. In geometry, the definition of dilatation is a transformation which is used to resize the object. Dilatation is used to make the object larger or smaller. This transformation produces an image that is the same as the original shape, but there is a difference in the size of the shape. A dilatation should either stretch or shrink the original shape. This transformation is expressed by the term scale factor. If a dilatation creates a larger image, then it's known as enlargement, and if a dilatation creates a smaller image, then it is known as a reduction. In the above figure, we can see the original ABC triangle is transformation into a bigger triangle, or it called an accent, B accent, and C accent after the dilatation process. Hence, it is case of enlargement of the size of an object or shape. Okay, now let's move into properties of dilatation. Some features of shape that remain unchanged during the dilatation transformation are: one is each angle of the figure is the same. The second is midpoint of the size of the figure remain the same as the midpoint of the deleted shape. The third is parallel and perpendicular line in the figure remain the same as the parallel and perpendicular line into deleted figure. Last, the image remain the same. Okay, so there are two types of deletion process. They are horizontal deletion and vertical deletion. For example, you can see in the slide. Okay, that's all about transformation. I hope you enjoyed this video and see you again. Bye bye.